Now that we've seen the idea of a degree, here's my question. Why on earth is the degree so important? Well, degree of a polynomial affects quite a few things. The degree affects the shape of our graph, the number of turning points that our graph has, and end behavior. And this concept of end behavior is really important, not just in our polynomial chapter, but when we get to pre-calculus and calculus, eventually end behavior is a really, really big concept for us. So end behavior is looking at what are the ends of our graph doing. Okay, so all polynomials that are in the form x to the n power, where n is even, in the long run, the ends will both go the same direction. Now, there are probably going to be a bunch of different bumps here in the middle. Like my graph here would be probably what something x squared looks like. But if I have an x to the 4th power, x to the 16th, x to the 200th power, I might have a bunch of different bumps here in the middle. But either way, both ends are going the same direction. Okay, and if you think of transformations, if there was a negative in front, instead of both ends going up, if there was a negative in front, both ends would go down here. But either way, even power, even degree, ends go the same direction. Now here is how we write our end behavior. We want to describe what's happening the farther our graph goes to the right, and we do that by saying as x approaches infinity. So as x approaches infinity, meaning the farther we go to the right, well, our y values are going up. So we say f of x approaches, since our y values keep going up forever, f of x approaches infinity. This covers what our graph is doing the farther we go to the right. We want to do the same thing going to the left. And we do that by saying as x approaches negative infinity. So the farther and farther we go to the left, we'll look at what our graph is doing. Our y values keep going up. So again, f of x approaches infinity. Now, if we have an odd degree, so x to the n power, where n is odd, your ends go opposite directions. This is what x to the 3rd power would look like. Our graph kind of levels off near the origin, but this end on the right goes up forever, this end on the left goes down forever. Now if I had a negative out front, again this would reflect, so my end here would be going up. My graph instead would look like this. Okay, let's describe our end behavior here as well. It's the same idea. I want to describe what happens the further we go to the right and the further we go to the left. As x approaches infinity, the farther we go to the right, look at what my y value is doing. My y value is going up forever. So as x approaches infinity, f of x approaches infinity. And the flip side, as x approaches negative infinity, the farther we go to the left, oh, here our y values are going down. So f of x approaches negative infinity. Okay, let's get a little practice here describing our end behavior. This is example 2a. What is the end behavior of the function y equals negative 2 x to the 10th power plus 8x to the 7th minus 4x to the 3rd minus 5. Well, end behavior. How on earth do we know what this looks like? You're probably thinking, I don't know, I've never seen an x to the 10th power before. I don't know what that graph looks like. But all of our even powers, all of our even degrees, the ends go the same direction. Okay, so double check first. Sometimes this first term isn't actually your highest power, or the term with the highest power. So double check, let's see, I don't have any powers greater than 10. So this is my term that's going to affect my end behavior. I have an even degree, which usually would mean both ends are going up. But look at the whole term. I have this negative here. So the negative means the ends are both going to go down. And again, I don't know what this looks like in the middle. There might be a whole lot of bumps in the middle. I don't really know. But I know the ends are both going to go down. So we write that end behavior by saying as x approaches infinity, the further and further to the right we go, what's our y value doing? Further to the right we go, our y value is going down. So f of x approaches negative infinity. The other way, as x approaches negative infinity, the further to the left we go, our y values are going down too. So f of x also approaches negative infinity here. Okay, and just to kind of show you what this looks like again, so you kind of have some confirmation that, hey, both ends actually do go down here. I'm going to show you guys a graph quick. Of what this would look like. So here's our graph of that function, and if you look pretty closely, yeah, there's a lot of crazy things happening here. Okay, so our graph has some weird little bumps here. It goes up and then kind of goes down, and all sorts of crazy things are happening. So my camera's trying to focus. There we go. So we have a bunch of different bumps and dips, but both ends go down. They both go down because of that negative in the front and that even degree.